Hello, everyone. Today we come in to show you how to solve a linear programming problem, which is a maximization or a minimization problem, right? And we're going to give this example right here. We're going to try to solve this example. All right, so the M is called the objective. M is the objective, all right? And these right here, these inequalities are the constraints. So we try to maximize this objective right here subject to the constraints. Okay. Okay, first what you're gonna do. So we're gonna try to plot this whole region. What region correspond to these four constraints? As you can see, we have to graph a couple of lines, right? So first, what you're gonna do first? So we're gonna graph the line x plus 2y equal 10. For that, we need a couple of points. As you know, if you refer to my previous videos, right, our preferred points will be always the intercept. The intercept will be good choice of the points. If y equals 0, I'm sure by now you guys are gonna go fast, right? If y equals 0, so x, x plus 2 times 0 equal 10, which means x equals 10. So my first point is 10, 0, which is right here. Okay, now if x equals 0 now, right, which means 0 plus 2y equals 10, which means y equals 5. We have 0, 5. So we have this one right here. So I'm going to just plot here. Here, I need me a lot of precision here. We need a lot of precision because we're trying to graph exactly this line right here. That's why I'm using my ruler in order to graph it exactly. All right, so this looks good. That's my line. Now what I do now, I'm going to test 0, 0 to see where I'm at. Test 0, 0 to see if what side of the line I need to shade. Okay, when we test 0, 0, we have x plus 2y is less than 10. So 0 plus 2 times 0 less than 10, less than or equal to. 0 is less than or equal to 10, which is true. So I'm going to shade same side of 0, 0. Shade same side as 0, 0, right? Which is this side right here. Okay. Now, a little remark. You see these two inequalities right here? These two inequalities, they just ask you to consider only the quadrant one. Consider only the quadrant one, where x is positive and y is positive, which means now, instead of shading this whole thing, instead of shading this whole side, I just stop in the first quadrant, the first quadrant, which is right here. That's it. Because of the inequalities, x positive, y positive. Okay, now I'm done with the first two line. Second line, I'm going to take care. I change my color. I'm going to take care of this one now. Another is like the same job is 4x plus y less than 12. So graph the line 4x plus y equal 12, right? Again, same thing. We're going to go for the x-intercept and the y-intercept. So y equals 0, x equals 0. So if y equals 0, we get 4x plus 0 equals 12. The 0 is gone. We divide by 4, we get x equal 3. So we have the 0.30 right here. It's a 0.30, so 1, 2, 3, 0 right here. Okay, and then for the y-intercept, so we set x equals 0, we get 4 times 0 plus y equal 12. So we get y equal 12. So that's 0, 12. So we have 0, 12, which is all the way up here. Okay, so now again, I get my ruler out and graph the line. I get my ruler out. We're going to take advantage of the technology, right? Okay, that looks almost good. Okay, looks almost good. So we're gonna draw our line. Okay, so now, so we drew the line, and then we're gonna test the 0, 0 again to see which side of the line we're gonna shade. Test the 0, 0. We have 4x plus y is less than 12. Let's plug in 0, 0. 4 times 0 plus 0 less than 12, and that is true. Since it is true, same thing, we're going to shade the same side as 0, 0. We're going to shade the same side as 0, 0 right here. And we will not go beyond the first quadrant. We don't need to because of the two inequalities, x positive, y positive. Now, what is our region? What is a feasible region? It is a region where both shadings are, which is what? So we're going to take the green one, and that is right here. See, that is a feasible region. Okay. And we need to know what are the corners of this region. Okay, this corner is 0, 0 for sure. This corner is 3, 0 for sure. This corner is 0, 5 for sure. This corner is the one we have to pause a second and see exactly what is this corner. All right, so if our graph is correct, we can guess. We can see what is this point. This point looks like, 2, 4. This point looks like 2, 4, but we need to check. Not too fast. We need to check if this corner is really 2, 4. So if you do 2 plus 2 times 4, is it 10? That's 2 plus 8, which is 10. Okay, that's good. And then we go to the other line too. If say 4 times 2 plus 4, that's 8 plus 4, which is 12. That's good. Which means the 0.24 is exactly, our guess is correct. You know now why it is important to have a correct graph. If you have a correct graph, it can help you guess exactly what is a corner. If you don't have a correct graph, then it could be an issue how to get to that corner, you know. So we said we have the corners, so all the corners are 0, 0, 3, 0, 0, 5, and 2, 4. Okay, we're gonna evaluate the objective at each one of the corner. Evaluate M at each corner. Remember, m is what? M is 7x plus 9y. So m is 7x plus 9y. So we're going to evaluate m at each corner. So 0, 0, m will be 7 times 0 plus 9 times 0, which is 0. 3, 0, m will be 7 times 3 plus 9 times 0, which is 21. 0, 5, m will be 7 times 0 plus 9 times 5, which is 45. And finally, 2, 4, m will be 7 times 2 plus 9 times 4, which is 14, plus 36, which is 50. You see, we were looking for the maximum, and algebra rules tells us the maximum is only reached at one of the corners or at a corner. The maximum or minimum will be reached at a corner. Since these are the only corners, then the maximum will be at this point right here. Okay, because this is the maximum. It's going to be maximum of m is 50, reached at the point 2, 4. And that's it. You know, that is how you solve a linear programming. So now, if you look at the math side of it, the calculation side of it, as you can see, is all about graphing lines, testing point to shade one side of another of the line, and then evaluating the objective. I don't say this is not math heavy. It's not like Gauss elimination that can have a bunch of fractions. It is not. So I encourage you to practice how to graph correctly a line and what is the process to shade one side of another of the line. I encourage you to do that. Thank you very much.